Okay, so good evening, everyone. Am I audible?
Good evening, sir.
Good evening,
Okay,
sir.
so let's start our today's lecture. Okay, okay. So in our previous classes, what we have covered. So in our previous classes, we have covered till our entity relationship diagram. So now you have an idea about entire entity relationship diagram, why we are basically creating entity relationship diagram. So this is the first question that comes into your mind. So that question is basically in order to create a conceptual design. In order to create a conceptual design. So whenever you are designing any database management system, and if you are working in any project, so your first task is after your requirement analysis is to design a conceptual design. So in conceptual design, what you do, you basically use this ER model. So ER model is a very popular model. So in most of the companies, even though they are using your different kind of your notations, so, but still they are using your ER model. Okay, so we are basically following one or two kind of schemes in this in our entire you can say that course. But still, if you will see that there are in my last class, I have told you like okay, there are some chance notation you are having like UML notations like that. Okay, so what we have done, we have learned about our entities, what are our entity set. So these are the important things that are required. So first of all, in this lecture, we are basically going to discuss about your entity, your EER model. Okay, we are going to discuss about EER model. But just before starting this EER model, our new topic, I'm just going to discuss about the steps in designing an entity relationship, your schema. So whenever you are going to design your entity relationship schema, so what are the things that you need to consider? Okay, what are the points you should have an idea about all those points? So first one is related to your identify entity types. So whenever you are getting any question, okay, related to your entity relationship diagram, that first thing you need to design an ER diagram. So first thing that point that triggers into your mind is that you have to figure it out and find out your entity types. Because as I've told you, because your entity type will be your noun as well as your attributes will be what your noun. Okay. So how to whom you will make attribute and to whom you will make entity. So these are the very important thing because sometimes you will make, so you cannot make name as what your entity type. Okay, you cannot make name as a entity type, but it depends upon the scenario. Okay, so in some scenario you will make your something like course name as what your course name as your attribute, but it might be possible in some scenario you will make your entire course as what your entity type. This is how basically your main task is to basically figure it out that what will be your entity type and what will be your attribute. So entity type is basically a collection of similar kind of your entities through which what you can do basically they can distinguish among each other. Okay, so you have to distinguish it. So what is an entity? Entity is basically it is a distinguishable object. Okay, it is a distinguishable your object. Okay, so once you have an idea about what will be your entity type and what will be your attribute, your second task will be you figure out the relationship type. So as you have an idea about that in our entities, we are having different kind of entity types. Whenever you are designing any application or any database management system, or sorry, any management system, like for example, hospital management system or any like customer relationship management system like that, so you now you have an idea about that it might be possible that in your system you are having a lot of entity set. So how you are basically going to provide a link between these two entity set using with the help of your relationship. Okay, so now after that, your second task will be it's to figure it out like what will be the relationship. First thing, whether can we establish a relationship among these two entity set or not? If yes, then what kind of relationship this we can hold among these two entity set? Okay, so your this thing will be what your association among your two entity set. Once you have an idea about your relationship types, what will be your relationship type, then you will go for different types of. So in our relationship types, we have gone through like different kind of degrees. Okay, like whether it will be one to one, one to n, and many to many, or like that. Okay, so this is how basically you can go through the entire thing, how they are going to associate the attributes. Okay, and if you have created your entity set, so in this entity set, how many attributes you are having, and all these attributes, like we have also covered, like there are different types of your attributes. Okay, we have classified as like simple, composite, as well as your derived, stored. Okay, all these attributes. So how you are going to associate these attributes over there? Now, after that, once you have an idea about all these things you have covered, after that, you have to figure it out like what will be the domain of your attribute. So domains, students generally get confused like what is a domain. So in future, if somebody is going to ask you like what is the domain of an attribute, so set of permitted values. Okay, set of permitted values. So it might be like if you are, even though if you are writing int. Okay, so these are the set of permitted values. Now your for example, if I'm going to write your roll number. Okay, roll number should be of which type? Your integer data type. Okay, it should be of integer data type. So it means now you can enter only integer based value. It's not like that you can put characters over there. So now we are ensuring, and similarly it might be possible that in future we are going to add some sort of values, like our values should rely between 1 to 5. So now the domain of my this thing of my roll number will be what? 1 to 5. Because why? Because being an integer, we have also added some sort of your constraints. Okay, the constraint will be the roll number should lie in between 1 to 5. Now, after that, once you have an idea about your entity set, the relationship among these two entity set, okay, and you know that that entity set will have how many attributes, what kind of attributes. After that, you are also going to, it is mandatory because to make, because our main task is to go for a strong entity set. So in our last class, we have also discussed about strong entity set as well as your weak entity set. So in most of the scenario in your ER diagram, it is mandatory to have at least one entity, strong entity set. If you don't have any entity, strong entity set, then it is not an ER diagram. Okay, because as you already know that our weak entity set is basically dependent on your identifying relationship towards your strong entity set. Okay, so strong entity set is required. Even though, so if your ER diagram is having only weak entity set, then we cannot say it. Okay, that it is a very good ER diagram. Okay, why? Because you cannot distinguish it. You cannot distinguish the entities within a entity set. So how you are going to distinguish? So suppose if you are having a table, so in that table, how you are able to distinguish between these? For example, it is having three your rows or three tuples, or sometimes we also call it as entity. So in this entity, how we are going to distinguish it? Using with the help of primary key. So we have to determine also what will be the your primary key of this relation, your entity set. Okay. Now, if you have an idea related to that, after that, our second last task will be what? Associate cardinality ratio, and you also can show the participation also. So we have also gone through what will be the cardinality ratio. So we have gone through in the depth of all those things. The concept like what will be your cardinality ratio? Cardinality ratio is equivalent to your maximum cardinality. Okay, the number of times an entity is participating in that relationship will be your cardinality. So maximum will be your cardinality ratio and minimum will be your participation. So we have also covered so far your minimum. So now after that thing, this last point will be design, generalization, specialization, hierarchy. So in this lecture, we are going to discuss about this part. So till now, I think most of you have a very clear about idea about like what are our entity set or entity type. Sometimes it is also known as entity type also. Okay, so entity set as well as entity types are same, and you have an idea about relationship. You have an idea about your domains. What will be your primary key? What will be your cardinality ratio? What will be your total participation and your partial participation, like that? Okay, so this point we are going to cover in this lecture. Now, now I think most of you will have now a very clear idea about what this ER diagram is now going to be representing and what will be the case study. So suppose being a conceptual designer, there is a conceptual designer, and that conceptual designer gives this ER diagram to you. Then now you are in that position that you will be able to understand each and everything related to this ER diagram. So as you can see over there, for example, this is a employee management system of any university. Okay, this is a employee management system, for example, for any university. So these are nothing but these are your entity sets. So how many entity sets we are having? Employee, department, project, as well as our department. So these four are what our entity sets. Okay, how many entity set we are having? One, two, three, and four. How many strong entity set we are having? We are having three strong entity set. This employee, department, project, but this is not a strong entity set. This is known as what our weak entity set. Why this is a weak entity set? Because weak entity set is represented using this over to you can set a double line rectangular kind of thing. Okay, so this is how you are going to represent your weak entity set. Weak entity set. Now as you can see over there, employee can have a different kind of attributes. So all these are what your attributes. So this, or we can say that all these are what your simple attribute, and this attribute is what it is a composite attribute. Why? Because this attribute can be further divided into your simple attribute. Like your name can be divided into your first name, middle name, as well as your last name. So we have also discussed in our classes also that what are the different types of attributes. So we have discussed everything. Now this SSN, your we can also say it like social security number. So this SSN is we have made it as what your make it as a primary key. So whenever you are getting a underline thing, okay, whenever you are getting underline this thing under this your any attribute, so this is known as what your primary key. So for my employee, so entity set is nothing. Whenever we are going to, you can say that map our this ER diagram in our relational table, relational database management system, then we will make employee as a employee. This entity set make it as an entire table. So in that entire table, how many columns we will have? We will have all these columns. And after this, we will make SSN as what our primary. Now, now, as you can see over there, in this example, employee supervision employee. Okay, so here we are getting what kind of relationship. So we have also gone through the what will be the degree. Okay, what will be the degree of our employee. So here we are getting your recursive relationship among this entity, because here employee is supervising employee. So it might be possible that there will be some employee who comes under a category of your you can say that your employee, but what they are doing, they are supervising those employees. Like I have given you an example of HOD sir. Okay, so HOD sir, what he is doing, he is supervising other employees like us. Okay, so this is how basically this relationship is known as what your recursive relationship. And also it is also one thing which I haven't covered in my class, is that it might be possible that within two entity set there might be more than one relationship. Okay, there might be more than one relationship. As you can see over there, employee works for department, so this is one relationship, and employee manages your department, this is other your you can say that your other relationship. Okay, so one more thing is this double line. So double line is going to tell us about that participation. Means all the employees. So suppose if in our department we are having 5 employees, so it means all the five employees are participating in this. Your you can say that in this department, or means all the employees are basically participating, means they are working in under in any department, it whether it is CSE, EC, any department like that, but they are working. It's not like that there is a employee who is not working anything, but we are also putting that employee in that entity set. Okay. Similarly, as you can see over there, employee manages department, but for this, as you can see over there, but for this relationship, we are not showing what you can say that your total participation, because because it might be possible there are some employees who are not managing the department. For example, HOD sir. Okay, so HOD sir is managing the department, but we are not managing the department. So that is why it means there are some entities of this entity set who are not basically participating in this relationship. Hence, we are getting what your partial, you can say, that relationship, and so on. Okay. And similarly, as you can see over there, this weak entity set. So in our previous lecture, I told you that it is mandatory whenever you are writing, making anything as a weak entity set. So the kind of relationship it holds, this relationship is known as what your identifying relationship. Okay. This relationship is known as what your identifying relationship. And these two lines, so whenever you are basically drawing any weak entity set, it is mandatory that from the weak entity set, if it is participating in any identifying relationship, so from their end, from weak entity set, it should be a total participation. Okay. It is mandatory that it should have a total participation. Okay. Otherwise we will get redundancy, and we will be in a big trouble. Okay. We are not able to identify some of the entities of that your weak entity set. Okay. So these are the things. And in this department, as you can see over there, we are having this. I have used this location. What it is telling us, it is going to tell us about, okay, we are using this multi-valued attributes. Okay. So multi-valued attribute, so it might be possible that it is having some multiple values, like location. A department can have multiple locations. Okay, like that. So I think now you have an entire idea about this thing. Okay, so if you are able to understand this ER diagram, so I think now you have an idea about what is our entire ER model. But if you have any doubt related to that, you can directly ask me. Okay, that if you are getting some sort of confusion related to that. And one more thing which I forget to mention over there is, this is one-to-many relationship. Okay, so it means that many employees are working in a single department. Okay, so I think I have shown you using with the help of this mapping technique. So using this mapping technique, you will see that the maximum cardinality. So what will be the cardinality of department? So we have to calculate each cardinality on the basis of relationship. Okay, so as you can see over there, for this relationship we will calculate different cardinality, and for this relationship we will have a different cardinality. So in this case, if you will calculate the cardinality, maximum cardinality of department, it will be what, n. Okay, and in that case, in this relationship, the maximum cardinality will be what, 1. Okay, like that. So I have shown you using this mapping technique that how we are going to calculate and how we are going to figure it out. What will be your maximum cardinality and what will be your minimum cardinality. Now, now we are going to we will move towards our entity relationship, this EER model. So first, what is EER model? Okay, so that is what known as what your extended as well as enhanced ER model. Okay, so what is EER model? So first we will see the definition. So entity relationship diagram are advanced database diagram, very similar to your regular ER diagram. So it's not like that now ER diagram is is not at all equivalent to your ER diagram. Both. So basically, what you are doing, you are using the concept of most of the all the concept of ER diagram, as well as you are using some your enhanced feature. Okay, you are using some extra features you have incorporated in ER diagram. That is why it is also known as what your extended or enhanced ER model. So which represent the requirements and complexity of your complex database. So in real scenario, as you can see over there, when data becomes so popular, you are getting a lot of data. The data becomes so humongous. So in that scenario, what will happen? The complexity is increasing day by day. Okay, earlier we are having, suppose if we are going to create employee, okay, employee entity set. Okay, suppose if I have created employee entity set. So earlier we are having suppose two kind of employee for a college, like teaching staff or as well as non-teaching staff. But nowadays, as you can see over there, in teaching staff also we are having a different kind of, you can say that, different kind of entities. It can be a professor, it can be a lecturer, it can be a, you can say that, assistant professor, associate professor, like that. Okay, so in order to reduce the complexity, what we will do, we will go for what your EER model. So why to go for EER model? So the additional EER concepts are used to model application more accurately and more completely. So whenever you want to, want that I should map my entire ER diagram more accurately, then in that scenario, what you do, you should go for what your EER model. So in ER, we are basically going in a way in the depth of this model. Okay, right now we are, so we'll see in an example. So in EER diagram, what others thing we are having? We are using the concept of your ER model, but what else we are having? So in EER includes some object-oriented concepts such as inheritance. So basically, we are using the concept of inheritance in the case of your EER model. Okay, so we will see why EER model is required. So you should have an idea if somebody is going to ask you, like, if you are having ER model, then why you are going for EER model? Because everything is very complex nowadays in your ER model, and you cannot basically define each and everything using with the help of your ER model. So in order to make things more accurate or more easy to understand as well as more complete, so in that scenario, what you do, you go for what your EER model. Now, so in extended, what are the extended features that have been added in our ER model? That is known as what your specialization, generalization, and inheritance. Basically, all these terms are somehow interrelated to each other. Okay, but the process is same, different. But the process is different. If we'll see, if we'll go one by one all these concepts, but if you'll see over there, then you will came to know about one thing, is that the concept is same but only the process is different. So in order to first understand about the extended feature of your ER model, so first thing, as you already know about, when we have discussed about inheritance, when we have discussed about inheritance in your Java, so what we are having a parent class, we are having a parent class, and we are having a child class. Okay, or sometimes we also call this thing as a super class, and we call it as a subclass. Okay, so different you have gone through, like we use different terminologies in our inheritance also. Similarly, here also we are using this terminology like your superclass as well as your subclass. So what do you mean by? So I think you have an idea about this inheritance. So in inheritance, what we are doing, we are basically creating subclasses such that subclasses inheriting the properties of your superclasses. Okay, so why, how we can use this feature in our ER model? So we'll see in this thing, in this lecture. Okay, so first thing is, what are your subclasses and what are your superclasses? So I think you have an idea about what are your superclasses and what are your subclasses. So superclass is your parent class. Okay, superclass will be your parent class, and subclass will be your child class. Okay, so I think you have an idea about this thing, what will be your parent class and what will be your child class. But why we are using this concept, superclass as well as subclass, in our ER model? Okay, so where we can use this concept in the case of this thing. Okay, so when you are having an entity type, may have additional meaningful subgrouping of its entities. So what you have, suppose you are having an entity set E1, okay, and somehow what you can do, you can divide this entity set so that everything will become more clear. And what you do, you divide it into E11, E12, and E13. So in that scenario, E1 will be what my superclass, and so what are the subclasses? Subclasses will be E11, E12, as well as suppose this is E13 and E13. So we want to make things more meaningful, and we just want to make everything should be clear. Okay, whenever we are designing our ER model, that is why we are going to use the concept of your subclass as well as superclass. So for an example, I can told you about that. Suppose if we have created a entity set of employee, okay. So we have created an entity set of employees. So earlier, what we have done, we have created this thing. Employee works for. Suppose this is department, okay. So this relationship is works for. So in our ER diagram, what we are doing, we are just designing this till this part, like employee works for department. Okay, many employees are working in a single department like that. Okay, so we have designed a ER diagram like that. Now in EER diagram, what we are doing now, we are basically classifying these employee into we are basically dividing this entity set into some subclasses, or you can say that sub entity set. And these entity set will be, for example, employee can be secretary, as you can see over there, it can be engineer, it can be technician, and so on. Okay, so somehow what we have done, we are now also telling our user also that it's not like, because employee is a broad word. Okay, anyone can be an employee. So what we are going to do now, we are also going to mention our user as well as our database designer is that we employ. So how many employees we are having? We are having only, suppose let's assume we are having only these three employees. So we are telling him, okay, we are having secretary, we are having engineer, we are having technician. Now it gives us more clarity regarding whenever we are designing our this our entity relationship diagram. Okay, so that is why what we are doing, we are basically dividing. Even though we can also divide, we can also draw this thing employee, everything will be okay. But what we want to make things more meaningful or more simple. So for that thing, what we will do, we will divide our entity set, okay, into some subclasses. These are also entity set. Okay, it's not like that, and they are also having the same properties. It means they, they are all, they are what your, if suppose this is a super strong entity set, then all these things will be what your strong entity set. Okay, so all, like they will also have entities, they will also have primary key like that. Okay, now, so as you so what we have do, what we can do, it's up to us. Okay, it's up to us being a data conceptual designer. Now it's up to you, like how can you classify your employee. So I can classify my employee on the basis of job, like it might be like your secretary, engineer, technician, so on the basis of manager, so the person who is managing, like manager, and on the basis of payment method also, like on the basis of payment, you want to make it like, I want to divide my employee into salaried employee as well as hourly employee. Okay, so it's up to us that how we are going to basically classifying. Okay, so going to create subclasses of that superclasses. So as you can see over there in this example, what we have done for a employee entity set. Okay, this is what my employee entity set. Now, till now, what we have done in our this diagram, we generally have worked upon this thing. Okay, this thing. Now, what I want to make things more generalized. Okay, so in that scenario, in order to make things more generalized and more clear or more meaningful, what I have done, I have basically classified, or you can say that I have created subclasses of this employee entity set. So how I have divided, on the basis of job, I have divided these things. On the basis of manager, I have divided this thing. And on the basis of pay, I have divided this thing, like these two things. no need to worry about what is D, what is this sign. We are going to discuss about that part. But right now, our main task is that how what we are doing, we are basically focusing upon superclass and subclass. So this will be what my superclass, and these will be what my subclasses. Okay, these will be what my subclasses. So as you can see over there, how many types? So I have created subclasses. All these are what the subclasses of this my employee. So how you are going to create these subclasses and what are these signs? So now we are going to discuss about that part. Okay. So, for example, how can you categorize employees in your Bennett University? So, suppose in Bennett University also, if you want to suppose I like in our example also, I am creating this thing. What entity relationship diagram of my Bennett University, like employee works for department. Okay, suppose if I'm just giving you a very simple kind of relationship. So, in for a Bennett University point of view, how many types of employees we are having. So if I want to classify, if I want to create subclasses on the basis of job type, so it can be a professor, data entry operator, clerks, gardeners, drivers, etc. Okay. So on the basis of this thing, if I want to create subclass, so I can also create subclass on the basis of what your job type. Similarly, we can also create deans also, like only deans manages a school. So suppose if I want to perform, because I don't want, because it's not like that every employee is managing the dean. So earlier what will happen if I want to create some relationship. Okay, so as you can see over there in this example, that employee manager, so manager is basically what managing the project. Okay, but engineer is not managing the project. But so in our earlier case, what we will do whenever we are going to create a relationship among your employee and your project. Okay, so what we will do, we will just write employee manages your project. Okay, but in reality, as you can see over there, all not all the employees are managing the project. Okay, not all the employees, because as you can see over there, we are having secretary, we are having technician, we are having engineer. So all these persons are not basically what managing the your project. Only the person who is only the entity who is basically managing the your project are your manager. So it's better what I will do, I will just break my this entity set into subclasses so that it becomes more clear. Now I will not say like that, okay, engineer is going to manage the project. No, engineers are not managing the project. Only manager are basically managing the project, like that. Okay, so now things will become more clear and more we can understand each and everything. Okay, or more meaningful, I must say. Similarly, if I want to classify, I want to create subclasses on the basis of job agreement also, like whether it will be a permanent contract. So it's up to you. Okay, so it's up to you. Like suppose if you have created an entity set in your ER diagram, so now what you can do based on, like if you'll see that, okay, I'm having some different kind of entity set, or I can create a classification among them. So it's better I can classify them on the basis of job type, on the basis of your management, on the basis of your job agreement, and so on. Okay, so this is not limited. So it's better if you can also add some more, you can say I must say that some sort of additional classification technique. Okay, or method. So whenever you are basically using, so in your inheritance in Java also, I think you have gone through, this is known as what your is a relationship. So a superclass, so a superclass and a subclass, and a subclass is having a is a relationship. So this kind of relationship is known as what it is known as is a relationship. So as you already know that every entity set, if we want to create, if we want to make a link between these two entity sets, so in that scenario we required a relationship. Okay, we required relationship set. So what kind of relationship set we are having is a relationship. Like earlier, as you can see over there, here, what kind of relationship we are having? You can say that manages, belongs to, all these are what? These are your relationship type. Okay, what will be like? These are your manages. manages is my relationship, okay, among these two entities. Similarly, whenever you are basically classifying, you are dividing your superclass into your subclasses. So the you can say that it is known as what it is known as. Always it is a relationship, okay? Because as you already know that secretary is a employee, your professor is an employee, technician is an employee, driver is an employee, like that. Okay. Now, as you can see over there, these are the points which you keep in your mind, that an entity that is a member of a subclass represents the same real world entity as some member of the superclass. So it's not like that in your subclass you are having some different kind of functionality. So in your subclass, so it means sub entity set also, it is also having the same set of operation like entities, and now you are able to distinguish among each entity. So the definition of entity set will be same, or even your attributes. Okay. So the definition, each and everything will be same. Okay, so one more point, this is very important, that it is not necessary that every entity in a subclass be a member of superclass. So it might be possible, but as you can see over there, a member of a superclass can be optionally included as a member of any number of subclasses. Suppose I have divided, so in this example, what I have done, I have created the classification on the basis of your job type, your manager, as well as on the basis of payment, okay, whether it is a your salaried or as well as hourly employee. So it might be possible that there is an entry in my employee table who is an engineer and working as a salaried employee. So as this is the statement, so a member of the superclass can be optionally included as a member of any number of its subclasses. Okay, so like a salaried employee who is an engineer belongs to two subclasses. So in future, if somebody is going to ask you like whether like an entity can works on two different subclasses, yes, you can make an entry on two subclasses also. Okay, like that. Now we are going to discuss about two topics, and these two topics are very important. First one is your specialization, and second one is your generalization. So what do you mean by specialization? So specialization is also known as what your top-down design process. Okay, it is also known as what it is known as top-down design process. So like I have already told you, what you are doing in your specialization, that suppose right now I am having only employee entities. Now later on, I just came to know about the classification and each and every scheme related to that. So based on that, what I have done, I have classified, I have created subclasses. So creating these subclasses from the superclass is known as what your specialization. So that is why it is known as what your top-down process. Why it is known as top-down process? So from the superclass, now you are basically what you are doing, you are creating subclasses. So we designate subgrouping within an entity set that are distinctive and from other entities in the set. Okay. So what you are doing, basically, you are basically creating the subgrouping. You are performing subgrouping. You are creating sub entity sets of this entity set. Okay, so in most of the book, you will see that it is represented like this, is a diagram like that. Okay, is a diagram. So as you already know that in your specialization as well as generalization, we are using the concept of what your inheritance. Inheritance means, suppose, let's assume now I will take this example. So what I have done, I have divided this employee, I have classified this employee, and I have created subclasses based on your, as I've told you, job role, manager, as well as pay. On the basis of pay, I have created subclasses. So as you can see over here, this sign. So in every book, you will see different sign, but most common sign is either is a you will see, or you will see this sign. Okay, you will see this sign. So this sign is going to tell us about, okay, you are performing specialization. Specialization means you are now performing is a relationship, and you are basically dividing. Okay, you are creating subclasses of my this super class. Okay, you are creating your subclasses from this super class. So as you can see over there, this is known as what your specialization. So whatever the thing you are seeing over here, this is nothing but a your specialization. So whenever you are seeing this kind sort of sign, okay, among two your entity set, then you will say it like, okay, we are performing a specialization. Okay, so the direction of this thing will be like this direction. Okay, it's not like that, it is not in that direction. Okay. So as you can see over there, so here what we are doing, we are basically dividing it, our employee into our different categories. So basically, as you can see over there, this secretary, because we are performing inheritance also, so secretary will get by default these attributes: name, SSN, birth date, as well as address. So we don't need to again this write all these attributes again like that. Okay. So secretary, all these things are what inheriting. It is inheriting from our superclass. So why I'm not focusing a lot in this topic, because you have an idea about inheritance, because we have already covered in our Java programming language. So as you can see over there, what you are doing, like name will be here. SSN, even in the case of technician, engineer, so everything you will get it. Whatever the thing you will see in our superclass, you will see. So in specialization, what you are doing, you are breaking down, you are creating subclasses from your superclass. Okay. So that is why it is known as top-down approach. So from the top end side, what you are doing, you are dividing into your, and you are creating different your subclasses. So the distinguished features of it, so the job of the, so on the basis of job, and that the person is temporary employee or permanent. So on the basis of what you can do, you can basically create your specialization. Okay, suppose if there is a person, okay, and person, suppose let's assume if I want to draw, this is an entity set. Okay, and now what I want to perform a specialization over there. So what I will do, I will do it, and I will make it as what, sorry, this dot, I'm also going to explain this part. Okay, what this circle and what this D is going to represent. Just first of all, just understood this part is that what we are doing, we are basically performing specialization over there. So like for here, for this case, what will happen, suppose if we are having a person. Okay, and as you can see over there, it can be a temporary person as well as a permanent person. So how you are going to do it? So you will use this sign, okay? And based on that, now you can create your temporary person as well as your permanent person, because the your this thing, your characteristic will remain same. Okay, so whatever the, now you don't need to classify each and everything. So whatever the thing you are going to classify over here, these are basically what you can say that different or distinct, or you can say that disjoint attributes. Okay, disjoint attributes mean technician is not at all required at this typing speed, but secretary is required the typing speed, use speed. Similarly, technician is not at all required T grade. So that is why you will see that I haven't mentioned this thing, typing speed over here. Why I haven't mentioned this thing? Because only this secretary is using this attribute. So so you have to mention only those attributes in your super class, which are basically going to be used by your all your subclasses. If they are not going to be used by your subclasses, then no need to mention it. Okay, so that is why what I have done, I have mentioned this subclasses, these things. So all these things are what the attributes of your subclasses, subclass entity set, like that. Okay, now one more thing, one more topic, that is known as your specialization lattice. So specialization lattice is nothing but you can say that it is a multiple inheritance. It is a multiple inheritance. Okay, so what is a multiple inheritance? So in Java, we have also discussed about. So suppose if you are having a parent class P1, and if you are having a parent class P2, and if suppose if you are having a subclass, okay, if you are having a child class, suppose if you are having a child, so what you are doing, it is inheriting from both the classes. So this is known as what your specialization lattice. So as you can see over there, we are having two super class. We are having two super class, and based on that, what we are doing, we are basically creating, or we are basically categorizes. So this subclass, you can say that this my child subclass is inheriting the properties of my P1 parent class as well as P2 parent class. But So whenever you are basically working on your specialization lattice, so it always works on the second level. It is always worked on the second level, not in the first level. So this is what my first level. Okay, so as you can see over there, here you will not find any kind of, you can say that lattice. Where you will find the specialization lattice in the second level. Okay, in the second level. So like engineer manager. So as you can see over there, what is the characteristic of engineer manager? So engineer manager is basically holding the characteristic of your engineer manager, as well as it can be a salaried employee. So that is why what we have done, we have specialized over here. Okay, so it is basically inheriting. We must say that it is inheriting the properties of your engineer manager as well as your salaried employee. So if you want to show the multiple inheritance in your EER diagram, so the terminology which we are going to use it over there is specialization lattice. Okay. For example, here in this example, what will be your specialization lattice? Our specialization lattice, will it be a specialization lattice? No, it cannot be a specialization lattice. Will it be? No, no, yes. So student assistant will be our specialization lattice. Why? Because it is going to be specialized from employee as well as student as well as from alumnus. Okay, sorry, not from alumnus, but it is deriving from, it is taking, or it is inheriting from how many, you can say, the entity set, your employee as well as a student. Okay, so that is why it is, this thing is known as what your specialization lattice. Okay, so as you can see over there, a person can be specialized as employee, alumnus, as well as a student. So earlier, what we are doing in our ER diagram, we are focusing upon only person thing. Now we are going in the depth of this part. Okay, so even we can divide a person into your alumni, employee, alumnus, as well as a student. Similarly, we can divide employee into staff, faculty, student, assistant, like that. Okay, and as you can see over there, I'm not writing all the attributes, because these attributes are going to be, even staff is going to get all these attributes like name, SSN, sex, address, as well as your birthday. Similarly, salary, it is also going to get it from here. Okay, but staff doesn't have this, your percent time, your degree, like that. Okay, it doesn't have these things attributes. Similarly, we have one more concept that is known as generalization. So generalization and specialization are basically equal, but only the process is different. Only the process is different. So in generalization, it is known as, what it is known as, called as bottom up approach. Bottom up. So in early, in specialization, what you are doing, you are having an entity set one, and now you are basically dividing, creating an special, you are basically creating subclasses. Okay, E1 and E2 and E3, for example. Now in generalization, what you are doing, you are having this E1, E2 and E3, and based on that, what you are doing, you are creating what it is known as event. So this is known as what called as generalization. So as I have told you, that a generalization is a bottom up approach. So our specialization is a top down approach. Similarly, our generalization is a bottom up approach. Combine a number of entity set that share the same feature. Okay, it's not like, so as you can see over there in this example, we are having checking account, for example, and savings. So what we are going to do now, we are going to merge this thing and going to make it as what your account entity set. Okay, so some of you might ask me a question that how we are going to figure it out whether we are performing generalization or specialization over here. We cannot say it. Okay, we cannot say it from this example that whether we are performing generalization over here or we are performing specialization over. It is just based on the way we are going to basically write our statement or explain our diagram. If we are going to say that earlier we are having checking entity set and saving entity set, and if we are going to merge these two entity set and we are going to create our super class. Okay, from subclass, if you are going to create super class, then it is known as what your generalization. Similarly, what do you mean by specialization? If we are basically creating subclasses from a superclass, so it is known as what So the sign, notation, everything is same. Okay, everything is same if you are basically working on in your generalization also. So the term generalization and specialization used interchangeably, and is a relationship you will also use it. Okay, so there are different notations also. You can use is a also, and you can also use this thing also. Okay, you can use this sign also, like in our previous example I have used. So this sign is a, as well as this sign, this notation is equal. Okay, both are same, don't get confused related. Similarly, we have an idea about inheritance, so that's why I'm not discussing that part now. Now, these are the constraints that are required in order to create your specialization as well as generalization. First one is membership constraint. So as I have given told you about that, suppose if you are having some your parent key, okay, your super class. So how can you suppose let's assume I am having my employee. Okay, an employee entity set. So how can I basically divide these thing into some subclasses? So we need to add some sort of what your membership constraint. So on the basis of membership constraint, what we will do, we will create subclasses. It's not like that I will create some subclasses randomly. No, we have to use these three, any one of these three your membership constraint. Whether you can use predicate defined subclasses. So what do you mean by predicate defined subclasses? So over there you are basically adding some sort of rules, some set of rules. Like for example, if I want to create an employee, okay, employee is my entity set, and I want to divide into, for example, two categories. So I want to create by my own, okay, like my experienced employee as well as my normal employee. Okay, I have created like unexperienced employee or my inexperienced employee, for example, I want to write it. So how can I add it? So I just want to add a predicate defined. So I want to add a rule. So what is my rule? So those employee whose experience is basically greater than 5 years. So I just want to put them in the category of my experienced employee. So this is how basically what I can do. I can create subclasses. So this is known as what your predicate defined subclass. So you can basically create. So in most of the scenario, you can basically create this predicate defined subclass. So this is how you can basically create your subclasses. Similarly, we are also having our attribute defined subclasses also. Like as I've told you, like in our employee, okay, in our employee table, we are having one constraint that is, for example, pay. Okay, so what we can do, we can using with the help of this attribute, or I have given you one example, like for on the basis of your, suppose I am having this account, okay, account, account entity, and now there is an attribute account type, account type. So as you already know that how many account we are having, either we are having saving account or either we are having your saving account and your current account. Checking account will use it what your current account. Okay, and either we are having current account. So on the basis of your this attribute, what you are doing now, you are basically creating the what you can say that subclasses. Okay, so that is why what you have done, you have basically created either your saving account and your current account. Okay, you have created. So based on that, what you have done, now you have basically created, you have basically performed the subclasses on the basis of attributes. So first one is a predicate, so it's up to you. Now you are basically creating different kind of rules, okay, on the basis of that thing you are creating. Similarly, last one is your user defined subclass. So in user defined subclasses like that, suppose I am having this student table. Okay, I am having a student entity set. Now what I want to create different groups. Okay, I have created EB01, EB02. So all these EB01, EB02, EB03 are what? Student. Okay, suppose I want to create like that. So all these things are what student. So but how I have created, I haven't used any predicate defined subclasses. I haven't used any, you can say, the attribute over there. What I want, it's my wish. Okay, I just want, okay, I just want to classify on the on my or just on the basis of, like, I just want to create different kind of you can say that subclasses. So these are known as what your user defined subclasses. Okay, so in most of the scenario, in generally, we are going to use what your attribute defined subclasses. So in your examples also, whatever the attribute example subclasses we are creating on the basis of your attribute defined subclass. Now, now we are also having this disjoint constraint, different kind of constraints. So first one we have created, completed our membership constraint. Then what do you mean by disjointness constraint? Okay, so disjointness constraint, as you already know the meaning of this word, that is known as what disjoint. So the subclass must have disjoint sets of entities. So suppose here is an employee. Okay, employee can be, let's revise this thing. Okay, now what I want to divide my into this professor and secretary, for example. Okay, now what I have done in this example, there is an employee entity set, and now what I have done, I have created a subclass name as professor and secretary from this my entity set. Okay, from this entity set. So whether it is a disjoint or whether it is a overlap. So whenever this set is a disjoint, so in over this circle, we are going to write D over here. Whenever we are having overlap, we are going to use O over here. So in this example, this is known as what? Disjoint entity set. Why it is known as disjoint entity set? Because whatever the entries we are going to put in this professor entity set, okay, or you can say that suppose this is a table. So in this table, we are having all the professor of our department, and suppose we are having some secretary. So is it possible that secretary come? We have to make an entry of some secretary in our professor set? No. So let's assume, I just want to give you S1. Suppose we are having employees, okay, E1, E2, E3, and E4. So as you suppose E1 and E2 are what your professor. So I have put over there E1 and E2. So that is why I think E1 and E2 will comes under category of my professor entity set, and E3 and E4 will comes under the category of secretary, because these two are your secretary. So as you can see over there, E3, we cannot make an entry of E3 in my professor table. Similarly, I cannot put an entry of your E1 in my secretary entity set. So it means these two entity set are what your disjoint entity set. Means they don't have anything in common. Okay, it means if you are going to if I'm going to write prof intersection your secretary, okay, then what I am going to get fire means, and then nothing is common. So even intersection E3 E4, what will be the value? Null value. Okay, or you can say that zero, like that you will get nothing whenever basically you are going to perform the intersection operation of this thing. Okay, so whenever you are getting some sort of values related to that, if not, then in the answer will be what your overlap. So the example of this thing is, suppose we are having an employee. Okay, now in this employee, what we are having? Professor, and we are having dean. Okay, we are having dean as well as professor. So as I think you have an idea about that, whatever the dean we are having in our college, they are also professor. Okay, they are also professor. So that is why we will see that there are some entries. They have an entry in the professor table also. It's not like that all the deans, all the professors will be in your dean table. Okay, no, only one or two, three values will be there. So in that scenario, whenever you are having some sort of overlapping of entities, okay, of the entities of this entity set, then we are going to use O over there. Okay. Otherwise, we will use D. So in mathematically, if I'm going to tell you about like prof intersection Dean, we are going to get some value. Like it should be like we will get some value, like whether we will get 1, 2. It's not like that. It's not equal to, we can directly say it like that, null value. Okay, we'll get some value over there. So hence this is known as what your overlap. So in your ER diagram, whenever you are getting this O, then it means overlapping. D, whenever you are getting, it means disjoint. Okay, so whatever the subclasses you have created, these two subclasses are having nothing in common. No entities are common in between these two tables. Now here some entities are common in these two tables. Okay, so as you can see over there in this example, so as you can see over there, this is known as what your disjoint, because car and truck, these two things are different. Okay, we cannot make an entry of truck in car, we cannot make an entry of car in truck. Okay, that is why I have written disjoint over there, and you can see over there the sign will be same. So this is also an example of your generalization also. So in generalization, earlier we are having car and truck. Okay, now based on that, what we have done, we have created a super class. Earlier we are having some classes. Okay, we are having these entity sets. Now based on that, what we have done, we have created a super class, or you can say that super entity set. It is known as what your vehicle. Okay, so this is known as what your generalization. So this is known as what your bottom up approach. So as you can see over there, the sign will be same. Okay, so no need to interchange the sign. If you are going to interchange, so things will get different. Okay, so the same. So that is why I have said that you cannot say that whether you are doing generalization or specialization by just seeing this diagram. You can say it like whether it might be possible that here will be specialization as well as generalization. It is only depends upon the narration or the scenario. Like if you are saying that earlier we are having only these two things, and now we are basically creating super class, then we will say that you over there you are performing generalization. Okay, like that. So this is an example of your disjoint. And in the case of your, as you can see over there, part, so part can be your manufactured part as well as your purchased part. Okay, so that is why it is also known as overlapping, because it might be possible there are some purchased part that are there in our manufactured part. Okay, so whatever the entries that are there in our purchased part, that should be in your, what you can say, that purchase part. So that is why I have written this over there. So this kind of constraint is known as what your disjointness constraint. Okay, this kind of, when you are able to find out whether it is D or 1. Now we are also having, yes.
Can you explain this part, disjoint constraint and this thing?
Okay, so shall I repeat one more time?
Yes, sir.
Okay, so let's start. I will give you one example. No issue if you are having any question related to that. Okay, so suppose we are having an employee table. Okay, we are having an employee table. Now what I want to add the functionality of EER diagram. So based on that, earlier we are having an entries of E1, E2, E3 as well as E4. We are having these four entries in our diagram, where E1 is my professor, E2 is my professor, E3 is my, for example, secretary, and E4 is also secretary, for example. Okay, so on the basis of job role, okay, on the basis of my job role, what I have done, I have basically created the subclasses. So how I am going to create the subclasses? I am going to write this thing, and now I have created two subclasses. So the first class will be what my professor, and second class will be what my secretary. As you can see over there in my professor table, I will also, what are the entries will be there in my professor table? E1 and E2. How many entities will be there in my this entity set of professor? Only E1 and E2. What will be the entities that will be there in my secretary entity set? That will be E3 and E4. E3 and E4. Can I put in realistic scenario also, I'm asking you is that can we put this E3 in my professor entity set? No, we cannot put it. Okay, why? Because whatever the characteristics we are having, so what is an entity set? Entity set is a collection of entities which are having same properties, so does secretary will have the same properties of professor? No, so we cannot put E3 in which set? In my this professor set. Okay. So that is why here E1 and E2, if I'm going to basically perform the intersection, if I'm going to perform, let's assume in mathematically, I'm basically explaining you this part. If I'm going to perform the entities, whatever the entities they are having in these two entity set, and if I'm going to perform the intersection, so what the output which I'm going to get it 0. It means disjoint. Disjoint means nothing is common, no entities is common in between these two entity set. So that is why I am going to write it what I am going to write it D. D means disjoint, means nothing is common. So whatever the classification I have done in this based on these two sub classes, so in these two subclasses I am not getting any entities that are common in between these two classes. While in there might be some scenarios, like I have given you an example of employee, or I have given you an example of your this professor as well as dean. So because dean is also, for example, taking classes. Okay, dean is also taking classes, but I just want to create some different table of dean. So that is why what I have done, I have created a different entity set for only for dean. So if I want any information related to dean, what I will do, I will just call this table, this entity set, dean entity set, and I will fetch whatever the information I want to fetch it. But because dean is also a professor, because our dean will also a professor, then the entry will also be there in my professor table also. So suppose if I am having, suppose in this scenario, if I am having E1, E2, E3, okay. So E1 is what my professor, this will be my professor, and E3 is also professor, as well as what it is my dean also. So E3 is also a is a professor and a dean. So what I will do, I will make whenever I am putting my entry. So what entry I am going to get? What how many entities I will add it over there? E1, E2, and E3. Three entities entries I will add because I am having three professor, 1, 2, and 3. In the case of dean table, how many entries I will add right now for my current scenario? I will add only E3. Why I will add only E3? Because we are E1 is not a dean, E2 is not a dean, but we only E3 is a dean. Okay, so that is why I will put it over there. But as you can see over there, if I'm going to perform this intersection of these two subclasses, okay, now we are basically focusing upon the subclasses. So if I'm going to perform this intersection of these two subclasses, so the output which I'm going to get it over there is E3. Okay, so it means I'm not getting the fire. So it means there are some entities, these are what entities of these entity set which are common among these two entity set, which are common among these two entity set. Hence, we are going to write it over there is O. O means overlapping. It means some entities are overlapping among two different entity set which I have created. So now I am also telling my user also that whatever it might be possible. So now everything is clear from my end also. If I will see, okay, I will directly tell, okay, it might be possible that there are some, so professor and a dean will have a, you can say that some entities that are in common, okay, that are in common or that are overlapping over there. So this is known as what your disjoint as well as your overlapping. Okay, understood? Or
Yes,
any
I
question?
understand. Understand.
Okay, yeah. Now, now we are going to discuss about one more constraint that is known as what is completeness constraint. First constraint we have discussed about disjointness. Okay, disjointness. So in disjointness, we are basically discussing about the entities. We are focusing upon only on the entities, okay? Whether entities are overlapping or not, like that. But now, this the second one is known as what your completeness constraint. Completeness constraint is quite equivalent to your partial participation and total participation. So I think you have an idea about what do you mean by partial participation, what do you mean by total participation. Similarly, here also we are also using this completeness constraint in our this EER model that is known as you can see over there, total partial as well as what you can say it as total. So as I have told you over there, here also whenever you are basically creating, suppose this is E1 and E2 like that, okay, and suppose if each, suppose here I will explain you with using with the help of this mapping. Okay. Suppose this is my EMP. Okay, EMP and E1, E2, E3, E4. Suppose I am having 4 employees. Okay, I'm just giving you an example. Now what you are doing, you are basically using the creating subclasses. Okay, and now you have created a subclass, for example, professor, and different is for example your dean. Okay, suppose you have created dean over there, and in professor I am having an entry E1, E2 and E3. So what are the entries I am getting it? I am entering E1, E2, E3, and in dean I am getting E4. I am getting E4. So as you can see over there in this, and this is what I'm going to write it over there, O or D. For this example, I'm going to write O or D. I'm going to write D. While in realistic scenario it is not possible, but I'm just for this example I'm telling you it will be D. Why I'm writing D? Because nothing is common. No entities are common in between these two subclasses of entity set. Okay. So let's assume take a realistic scenario, and I'm going to write E3 over there. I'm going to write
Sir,
E3.
time over here, sir.
Yes, sir.
Sir,
What are you
time over.
saying?
Sir,
Okay,
time.
just I'm just completing this topic. Okay, I'm just completing this topic. Okay, so what will happen if I'm going to write E3 over there? So in E3, what will happen? So as you can see over there, how many entities I am basically covering in these two entities set? I'm covering E1, that is okay. I'm covering E2, that is okay. I'm covering E3, that is okay. And I'm covering E3, okay, that I have. But I'm not covering this E4 entity. What I'm not covering? I'm not covering this E4 entity. Hence, for this relationship, because as I've told you that within all these, whenever you are creating subclasses from a superclass, here you are having is a relationship. So how many entities are participating? Whether all the entities are participating in this relationship? No, not all the entities are participating in this relationship. Hence it is known as what it is called as partial participation. Okay, so that partial participation, I think that concept is quite similar, which we have learned in our ER model. So it is known as what known as what your partial participation. And suppose if I have written E4 over there also, suppose let's assume if I have written E4 over there also, now all the employees are there, whatever the categories I have created here. So hence I am going to show that it is a total participation. It is a total participation. So as you can see over there in this example, if I'm having any example, or I will erase something. Okay, so I have to erase something. Wait, let me erase it. Okay, so in this example, as you can see over there, every vehicle, those who are having this entry, let's assume every vehicle is having the entry of this truck, but in realistic scenario it is not like that. But I'm telling you, suppose vehicle is either car or truck, then I'm going to write what total participation. So all the property, all the entries that are there in your vehicle, or okay, in your vehicle, if that is there in your car and truck, then we are going to write what it is known as your total participation. While in the case of one more example, I think I have put it over there. Okay, I will draw one example. So the example will be, suppose if I am having employee, if I am going to write whether this employee is a full-time employee, okay, full-time employee and a part-time employee. So if you are going to basically make an entry of all these employees, so how you are going to, so I think you already have an idea about whether it is a full-time employee for that organization or a part-time employee. Otherwise, it is not a that person is not an employee. Okay, so based on that, it means whatever the entries that are there in your full-time employee as well as your full-time, if I'm going to perform the union, okay, full-time employee, union, part-time employee, mathematically I'm explaining, full-time employee, union, part-time employee, if I'm getting the union of this thing is what you can say that employee, okay, so all the entries that are there, then it means that I'm going to write that as what? This total participation. Hence, it means that from the employee, whatever the categorization I have made, so I have made in such a way that all the entities that are there in my this entity set table are basically covering either in this table, this entity set, or in this entity. Similarly, just this is my last example, and then I will just end this class. So what will be my example? For example, I will give you an example, artist. Okay, artist, and if I'm going to write whether it is a singer, this is a real example which I'm taking, and whether it is a actor. Okay, so why I have written this O over there? So it might be because there might be a singer, an entity singer who is also an actor also. Okay, like for example, Sonu Nigam. Sonu Nigam is a singer as well as an actor. Okay, while his career is not that much good in in this field, in acting field, but we are, for example, we are going to consider him in this entity set that is known as what your actor entity set. So that is why it is, we are going to say it as what your O. But we cannot make this artist as what your total participation. Because for example, let's assume in our this artist, we are having also director also. Okay, director entry, some director name. For example, I am having some entry of some of the directors. Okay, for example, the director. Can anyone tell me the name of any director? Okay, so for example,
Sir Mahesh Bhatt.
yes, yeah, Mahesh, but
Rohit Shetty.
nowadays all of you are basically following the news, huh? That is why Mahesh, but you have said.
Rohit.
For example, Ramesh Sippy. Okay, so as you can see that Ramesh Sippy is not an actor as well as not a singer. Okay, he is not a singer as well as not an actor, but he is also an artist. Okay, he is also an artist. So that is why what we are going to do, we are not going to write this double, because from this point of view, all the artists are not basically going to be, we haven't put it here in these two entity set. Okay, so that is why it is known as what we are going to say it like, from this point of view, from this artist entity set or super class, we are showing only partial participation. Okay, we are just showing partial participation. Okay, so this is all about the our today's class. So in today's class, what we have learned the concept related to our entity relationship diagram. Okay, EER model basically, and we have covered our what is our generalization, specialization, and all these things we have learned so far. Okay, so still if you are having any doubt related to any concept, so that is why I have conducted extra class, because so that I can take some extra time. Okay, because in normal days I cannot take some extra time. Why? Because you are having other classes also, so that you will understand each and every concept very easily. So that is why I am taking a lot of time in EER model also. Okay, so thank you all. So if you have any doubt, so just you can tell me. So those who are having any question, so they can directly ask me, and those who have who don't have any question, they can also leave this meeting also. Okay, so they can also leave this meeting. So anyone who is having any questions related to this EER model so far?